Plot a graph of the force causing the extension against the extension x. What is the gradient of the graph? In order to plot the graph of f against x, we must use the data obtained. A straight line graph was obtained after plotting the graph. The straight line graph indicates that the force applied on the spring is directly proportional to its extension. Hence, the spring obeys Hooke's law within the elastic limit. Next, to find the gradient of the graph, we must sketch a mini triangle along the straight line. Then, choose any 2 points and use it as the coordinates to obtain the gradient, which is 3 Newton-meter. Next question is how much work done in stretching the spring through 0.05 meter. Find from graph. As we learned from chapter 6, work and energy, we can obtain the work done by calculating the area under the graph.
But hey, how do we find the value of spring constant?
Yeah, I was wondering the same thing. How? The value of spring constant can be obtained by the gradient of the graph. So, the value of spring constant is 3 Newton-meter. We know that work done is equal to area under the graph, in this case, the area of triangle. Hence, the work done W is equal to 1/2 base times height. From the graph, we know that the base is equal to x and height is equal to f, and f is also equal to kx. Therefore, we can conclude that the work done W is equal to 1/2 kx squared. And then, to find the work done, just substitute the x and k value into the equation. The k value is 3 Newton-meter. Meanwhile, the x value is already given by the question, that is 0.05 meter. Hence, we got the answer, that is 3.75 times 10 power of negative 3 joule. The third question is how much energy is stored in the spring when it is extended to 0.05 meter. Before answering this question, we need to know what type of energy is stored in a spring when it is stretched. When a spring is stretched, it will possess potential energy, specifically elastic potential energy. The formula to calculate the elastic potential energy is 1/2 kx squared. Just like before, substitute both x and k value into the equation. Therefore, the energy stored when the spring is extended to 0.05 meter is 3.75 times 10 to the power of negative 3 joule.